Hello people, this is the first of the several video segments that I'm doing for homework number 10. However, in the first few couple of minutes, I would like to do a quick review of what's transpiring in this section 3.4. There is not much new here. We have seen all of this stuff in the context of unit circle without any references to angles. However, this particular section, chapter 3, in fact, they fall back on the concept of angle and define some of the old concepts. So, and that is this particular one is on section 3.4, which is the inverse function. So, a few facts about what uh, what we mean by what we write. Okay, so first of all, when you write, for example, sine inverse of x equal to y, this is the same thing as saying that sine of y is equal to x. Okay, as if you pretend you can multiply both sides by sine of by the sine operator. Sine and sine inverse operator cancel each other out, and you get x equal to sine of y. This is not multiplication, but if it helps you um, remember the meaning of it, that's fine. Okay, now notice that there's no way this number that you write on the right hand side, this number y, there's no way this can be anything bigger than 1 in magnitude, because I'm sorry, there is no way the thing that you write here in the x, there is no way this can be bigger than 1 in magnitude, because it's impossible for sine of y to be equal to something that is bigger than 1 in magnitude. For example, there's no way you can find a y such that sine of y is equal to 5 or minus 3, etc. Okay, so let's keep that in mind. All right, now when you write cosine inverse x equal to y, it has one and one meaning, and that means sine of y, cosine of y is equal to x. And the same comment applies to the value of x. You cannot put an x there which is bigger than 1 in magnitude. By the same token, tan inverse of x equal to y, it means one and only one thing. That means tangent of y is equal to x. Here, it really doesn't matter what you put for x. You can put anything you want and you get a number back. Okay, now, uh, obviously what we have done here, maybe knowingly or not unknowingly, what we have done, we have defined a brand new function called sine inverse function, cosine inverse function, and tan inverse function, which mean these things, and they have a domain and they have a range. For example, when you look at the functions, these are the function, this is the domain, and there is a range. Okay, when you write this function sine inverse of x, remember you can never put anything bigger than 1 and minus 1 in size, in magnitude, in that expression. So the domain of this is only numbers between minus 1 and 1. No problem. As far as the range goes universally. Everybody has agreed that the range of this function, in other words, the thing that it spits out, okay, the thing that it spits out, namely the y, goes between minus pi over 2 and pi over 2. Minus pi over 2 and pi over 2. Remember, this means the x's, this means the y's. Okay. Now, when you write cos inverse of x, this function, also it has a domain between minus and minus 1, but the range people have agreed that they're going to universally accept 0 to pi for that. Okay? And finally, the tan inverse function, you can put anything you want. That you can either write it like that, minus infinity to infinity, or the book calls it all real numbers. And what you get is always something between minus pi over 2 and pi over 2. Okay, remember, this this one is included. This is a bracket, but these are parentheses. Okay. Now, although they don't say it again in this particular chapter or section, actually, I will plot the graph of sine inverse function. It looks like that. Okay. Sine inverse function. So I'll draw the sine inverse here, cos inverse here. This is cos inverse and tan inverse there. This is a reminder. Tan inverse is very simple. You can put anything that you want, and it goes like this. Goes like this. So this is pi over 2. This is minus pi over 2. And as far as x goes, anything that you want. As far as the cosine inverse goes, it goes between 0 and pi. Not there. This is what I mean. Let me erase this for a second. Okay. Now the domain of that function is between minus 1 and 1. This is minus 1 and this is 1. And it looks like this. Okay, this height is pi. And of course, this height is 0. As far as the sine inverse function is concerned, it goes also between minus 1 and 1 for for x, and as far as y goes, it goes like this. Okay, so this height is pi over 2, and this is minus pi over 2. These graphs are not repeated in the present section, but I don't think it hurts if you see them again. All right, so let me minimize this, go to my homework problem. Okay, first of all, it says in this triangle, right triangle, we want to write down theta equal to sine inverse of what? Now, remember, when we try to fill in this blank, it means that the sine of theta equal to the thing that we're going to put in here. Just look at your diagram. Sine of theta is opposite to theta, which is 8 over 10, okay, over hypotenuse, okay? So this is 8 over 10. And when you look at B, cosine of theta, whatever it is that we put in this blank space, cosine of theta is going to be that. That's going to be adjacent, which is 6 over 10. And obviously tan, let me try to fit it in here. Tan of theta is opposite over adjacent. The opposite is 8. Adjacent is 6. 8 over 6. Okay. Excuse me. Oh my God. All right. So the next problem, number 8, and 8 through 14, says use your calculator to get these. Because when it comes to sine inverse, unless they're very straightforward number out of the table that you have to memorize, you need a calculator. Okay. So let's see now. Cos inverse, this is number 8. Cos inverse of minus 0.75. Okay. So we go to our calculator. Oh, by the way, I didn't read. Did it want it in degrees or did it want it in radians? It says approximate value of each rounded to 5 decimal places. Now it doesn't. It doesn't ask for. It doesn't ask for. It doesn't tell you whether it's degrees or radians. So I will do it in I don't know, radians. Okay. Okay. So let's go to a calculator. Free version. Okay, let me clear everything. Make sure that our mode is on radian. That's the way I wanted it. If you want degree, obviously you're going to use degrees. And then the first one is, what does it say? It says cos inverse of minus 0.75. Okay, so let me see. This is on radian as we wanted it, and now we're going to go and put the cos inverse, second function, cos inverse right there of negative, there's your negative 0.75, and the answer is going to be in radians, okay? Uh, and it also says round this thing to how many digits? 5 decimal places. What that means is that keep 5 digits after decimal point. So if the last 5 digits will take me to 5, but because the number next to it is 8, so this 5 is going to get rounded to 6. So the answer to this one is 2.4 2.41886. I'm not going to write it there. Okay, let's look at the second problem. Then it has number 10. Number 10, it says sine inverse of, I think it says 1/3. Sine inverse of 1/3. So let's get this thing. So second function, sine inverse 1/3. 1 divided by 3. Again, I'm getting my answers in radians. So here, you have to keep 5 digits after the decimal, which means up to this 3, okay? But because the number next to it is 6, when you round it, it becomes 0.33984. 0.33984, okay? Next one, tan inverse of minus 4, second function, tan inverse of negative 4. So it's going to be negative 1.3258. This 1 is going to become a 2. Negative 1.32582. This is a 2. That's what you write on your paper. Next one is sine inverse of minus 2. So sine inverse, second function, sine inverse of negative 2. Please keep in mind that these answers are in radians, because when you do sine inverse, cos inverse, tan inverse, you get an angle, and the angle is either in degrees or radians, but in the absence of any instruction, do it in the radians. So enter. Ooh, yeah. You don't have to be a genius to see that, because we cannot take sine inverse of a number that is bigger than 2 in magnitude, bigger than 1 in magnitude. This is minus 2. There is no way you can have an angle whose sine is minus 2, whose sin is minus 2. Okay? So that takes care of, this is why we got an error message, of course. Let's see now, where are we? We did these 2 boxes, and then I'm going to do the next one. Actually, this is also relatively straightforward. Let's do it right here. I'm not going to do it in a separate video. So it says find the angle theta in degrees rounded to 1 decimal point. So what do we have here? We have sine of theta in number 15. This is 15. We have sine of theta equal to 6/10, which incidentally is 3/5. You can just leave it like this if you want. So what we want is sine inverse of 3/5 equal to theta, but we want this thing to be in degrees. Okay? Now, of course, whatever the calculator is going to spit out is going to be between plus 90 degrees and minus 90 degrees. Remember, plus pi over 2 and minus pi over 2. That's the only thing that the calculator will spit out when you ask it to give you sine inverse. Now, What we should do is, let's go back here, check our mode, put our mode to, how do we get rid of this thing? 2, I suppose I say 2 to get rid of that. Quit 1. Okay, good. So let's go ahead to our mode and change the angle mode to degrees. Hit enter. Okay, it is in degrees right now. Okay, very good. Good. So now we're going to do sine inverse, second function, sine inverse of, it was 3 over 5, right? 3 over 5. 3 divided by 5. And it's going to spit out an angle in degrees. So 36 degrees, 0.8, blah, blah, blah. And then it says, of course, rounded to 1 decimal point. Okay, so that means 36.9. 1 decimal point means keep 1 digit. That means keep the 8, except that the one next to it is a 6 bigger than 5. So it's going to up this thing by 1. So it's going to be 36.9 degrees. So the answer to this is 36.9. Do not forget either to put this thing up there on the right top corner, right there, this, or write 36.9 degrees. Otherwise, it is wrong. Let's do number 16. Number 16, what do we have here? It looks like we have tangent, right? Tangent of theta, because we have the opposite and adjacent sides, you might as well use directly tangent. Tangent of theta is equal to opposite, which is 7 over 18, or theta is equal to a tan inverse of 7 over 18. Again, I want to remind you that there are many, many angles, infinite number of angles whose tangent is 7 over 8. To make sure that everybody gives the same answer, universally we have agreed that the angle that spits out, the calculus spits out, is always going to be between minus 90 degrees and 90 degrees. Minus pi over 2 to pi over 2. That is the range of tan inverse function. So let's go ahead here. Second function, tan inverse, what was that, 7 over 10? 7 over 18. 7 over 18. 7 divided by 18. And since our mode is in degrees, it's going to spit out degree. If you're keeping one significant figure rounded to 1 digit, so it's going to be 21.2 degrees. 21.2 degrees. So this is equal to equal to 21.2 degrees. Okay, so let me stop this thing here. I'll do the rest of the problem in another video.